Hi everybody, welcome to lesson 6 of our Trig unit. Today we're going to do problem solving, and actually we're going to combine lesson 6 and 7 because both lessons involve problem solving. So I'll do a few examples from each lesson, but I won't cover all of the class examples. You can try some of those at home. All right, let's jump right into it here. So now that we know all our trig functions, we can start doing some different problems. And see exactly where trig can help us in the real world. So this is a very, as you're going to see, a very applicable topic to know. Okay, so example number 1, Carmen is a surveyor who's using transit to determine the height of a tree. The transit is placed 52 meters from the base of the tree, and the angle to the top of the tree is measured to be 12 degrees. So there's a diagram here for you. Most of the time you're not going to get a diagram, so you will need to be able to come up with pretty good diagrams here. Okay, so if the transit is 1.8 meters high, that's important here because it's not quite a ground level here. So that little space here is 1.8 meters high there. Calculate the height of the tree to the nearest tenth of a meter. Okay, so when we do our trig here, we're going to get this height over here. So after we calculate that, we have to add the 1.8 meter. That is the height of this tool that measures the height. Okay, so we have the distance from the transit to the tree. So, and we also have the angle here. So the angle, the height of the tree, or at least this part of the tree, is the opposite side with respect to this angle over here. So let's go ahead and use our tan ratio. Tan 12 degrees will equal opposite. Let's call this x just to be precise here. X over 52 because it's opposite over adjacent. So then finally I got to get that 52 over. I'll multiply both sides by 52. 52 tan 12 is going to equal x. So on my calculator, I'll go 52 tan 12, and that's 11.05. So finally, I'm going to add the 1.8 plus 1.8, which is this lower distance down here. I guess nearest tenth of a meter, so it's going to be 12.9. 12.9 meters is x, so the height of the tree is 12, almost 13 meters. Okay, determine the angle the base of the transit makes with the top of the tree. Answer. Okay, so now a little bit of a twist here. So the base of the transit is down here, and what angle does this now make from the from the base of the tree, from the base of the transit to the top of the tree? And let me go ahead and label this entire distance now. The entire height is 12.9. So how can we calculate this new angle? Well, we're just going to take into account this entire height, which is the opposite, and distance obviously stays the same. So again, that's the tan ratio. So it's going to be tan, and let me call this, I'll call it theta. Theta is a common Greek symbol used as a variable for an angle. So tan theta is going to be opposite of our adjacent. So 12.9 divided by 52. And on my calculator, I have to go inverse tan 12.9 divided by 52 in order to get theta, which is about 14 degrees. Now, what is it answered to the nearest? I should read that before I start. Nearest degree, so we have 14 degrees. 14, so theta equals 14 degrees. Does my answer make sense? Clearly does. If this angle is 12, and all of a sudden I get a lower, I measure it from a lower point on the diagram here, this angle is going to be slightly bigger. Let me draw it in green here. So I have this angle here versus this angle over here. So this one's going to be slightly more the second one here. Okay. Let me skip example number 2. What else do we have here? Yeah, let me try. Yeah, I think you guys can do these examples. Let me look at these bearings here, and this is also very common in navigation. It's measured based off a 360 degree. Obviously, that's a full circle. So usually north is measured as 0 degrees. So if you're heading north, you would say I'm heading in the direction of 0 degrees, and it's measured clockwise here. So as you move away from north, if you move to the right, you would say, for example, this boat is on a bearing of 40 degrees. Okay, so if you told that to somebody, they would know precisely which direction you're traveling in, because we always measure clockwise from north. Okay, and then you can see down here, if I'm saying 150 degrees, well, I'm going the opposite direction, southeast here. This is a big angle of 225. I would be going southwest. And then northwest over here would be 330. I wouldn't say 360 degrees because that would basically be the same thing as 0. So do get familiar with bearings. So when you start doing vectors in Physics 11 next year, this will really come in handy. Okay, so let's go ahead and do one of these problems. So a ship travels 6 kilometers from port P on a bearing 120 degrees. So there's a diagram here for you, but that would be the 120 degrees to position Q as shown. So the ship goes over here. The ship changes direction at Q and travels north until it reaches a position R, which is due east of P. Okay, so let's dissect that statement a little bit. The ship changes direction at Q and travels north. So from here it goes north. It goes north until it reaches a position which is east of P. Well, east of P is, let me move this over a little bit. East of P is over here. So this ship goes north until it kind of is perpendicular to P over here, or parallel rather. All right. So how far east of P is the ship at position R? So what are we looking for? Let's first of all give this guy a big R here. So how far is the position R from P? We're looking for this distance here. I'm going to put it like that. X equals, that's what we're trying to find out. So that's the distance there. Answer to the nearest tenth of a kilometer. All right, so what do we know? Okay, this is 120 degrees here, but I'm not really interested in that angle. First of all, you have to make some assumptions here. Well, not assumptions. You have to figure out where your right angle is. If that's directly east and that's north, that will be a right triangle with a 90-degree angle over here. So we need to calculate this angle over here. Well, I know that this is 90 over here, so 120 minus 90 is going to give me the rest of the angle over here. So that's going to be 30 degrees down here. Okay, now I'm looking for X here, but I do need to know one of the other sides, and I think that's this piece of information over here. Ship travels 6 kilometers. Well, that distance is 6 kilometers from P to Q. So now I can go ahead and do this problem. I have the hypotenuse, and I'm looking for the adjacent side. So we'll use the cosine ratio. So cosine 30 is going to be adjacent over hypotenuse in this case, okay? So that's going to be 6 cos 30 equals X. Get my calculator out. 6 cos 30. I get about nearest tenth of a kilometer, so 5.2 kilometers equals X. And that makes sense. Again, if I got an answer that was bigger than 6 kilometers, I would be worried and I'd be double checking everything. The ship continues traveling north for a further 12 kilometers to position S. All right, let's do that in black here. So, and continues traveling north for 12 kilometers, so probably a little further up here, 12 kilometers. For an additional 12, that's going to be that distance there. Determine the bearing of S from P. Okay, of S from P. Well, this is S over here. Let's give that a big S. So we're looking from a bearing of S from P. So be careful the way this is written down here. If it said P from S, it'd be going the other way. So let me connect this. I'm running out of colors. I think I haven't used blue very much. Let me do blue. So I'm looking for a bearing from P. Okay, so from P, what is this bearing? And that bearing is going to be over here, as our bearings are always measured from the north. Okay, but in order to get that, I will need to get this angle over here first, and let's call that theta. And once I get theta, I will just subtract that theta from 90 in order to get this piece over here. Well, I have the 12 and I have x, which are the opposite and the adjacent with respect to theta. So it's going to be tan theta equals opposite, which is 12, and adjacent, well, adjacent is the original PR distance, 5.2. So inverse tan, it's going to be 12 over 5.2. On your calculator, inverse tan 12 divided by 5.2, and you get 66.6 here, probably to the nearest, let's measure it to the nearest degree. So that's going to be about 67. Theta equals 67 degrees, and that makes sense. That looks about a 66 degrees there. Now, to get the bearing, I have to subtract that from 90. So 90 minus 67 is going to get me 23 degrees, and that is your final answer, as that is over here, 23 degrees. That's the bearing if this is 67 degrees over here. Okay. Oh, no, one more question. If the ship maintains an average speed, okay, so now we're getting some different questions here. If the ship maintains an average speed of 9 kilometers an hour throughout the journey, determine the nearest tenth of an hour, the time taken for the journey. So this is now not really trig anymore. It's more of our kind of a systems unit. We have to come up with an equation to solve this. I'm going to skip on that one and jump right into the next lesson. I want to get 2 lessons out of the way. I think we can handle that for this video. So lesson 7, more problem solving, a little harder problems. Let me jump to a maybe more difficult one down here. All right, problems. So problems in 2 dimensions. Kind of that's the theme here. Problems in 3 dimensions. I think I'm just going to do this hard one. Well, you'll see it won't be that hard, but you have to come up with a good diagram. Problem in 3 dimensions, and you're going to see a question on the provincial exam that looks kind of like this. So this is why I wanted to do this one right here. All right. Okay, so the solid in the diagram was formed from a rectangular prism by removing a wedge. Okay. So the wedge was probably kind of, if this kept going this way, this would eventually kind of make a wedge like this. Well, kind of went off from there. So if you can picture that wedge there, that wedge was removed. Okay, let's go ahead and do this. So HD equals GC. So HD equals GC equals 5 centimeters. So 5 centimeters, 5 centimeters. And EA equals FB. So EA equals FB, and that's 2 centimeters. 2 centimeters. Okay, and AD is 6. AD is 6 centimeters, and AB is 8 centimeters. Okay, so 8 centimeters. Now we have all the dimensions here. Name 4 rectangles in the diagram. Okay, the 4 rectangles in this diagram would be, I'm going to highlight this and then undo it because I don't want to keep my well, maybe I can do all of them here. So there's one back there. That's the back kind of face of this. There's the front face. Okay, and then you have the top and the bottom, which I think everybody can see. That would be the bottom there, and the top would be this one down over here like this. Okay, so super messy. Now I'm gonna actually just erase all those because we don't really need them. Okay, there we go. So calculate the measure of the angle HEA. HEA, okay, well that's going to be, first of all, HEA, always look at the middle letter. HEA would give us that angle right there. All right, well, first thing I need to do is if you can sort of picture this diagram, looking at it from this side over here, you would see a shape that looks like this. And just bear with me here while I do my best diagram here. You would see a shape like that. Okay, and the angle, this would be HEA, HEA like this, and the angle we're looking for would be that angle there, and I'll call it theta. That's what we're trying to calculate to the nearest degree here. But in order to make sense of this diagram, I know this is a funny shape here. I don't really know what the shape is. It's sort of half a wedge, or but it's made up of a rectangle and a triangle. And the way you have to make this more reasonable, you have to manipulate this diagram by cutting away, not cutting away, just kind of making a line that separates this shape into two shapes that and that is a rectangle and a triangle, and more specifically a right triangle. Well, right away I know that this now becomes a 90-degree angle. So as long as I calculate this little angle over here, I can add that to 90 and I will have my theta. So I need to, I'm going to do it in black here, I need to calculate this little angle, we can call that x, down here, and I'm going to add that to 90 to get theta. Okay, well, what do I know? I need to label this diagram with some measures now. I do know that, again, you have to kind of manipulate your diagram here. This was 2 centimeters, EA, so that's going to be 2 centimeters, which means that that's going to be 2 centimeters as well. And if this whole thing, this is D, by the way, and if HD was 5 centimeters, that leaves this portion here to be 3 centimeters. Okay, almost there. How far is DA? Well, DA is 6 centimeters. 6 centimeters, which means that this is also 6 centimeters from E to this point over here, which I haven't labeled. So now I'm going to pull this triangle out, and I have this, and blow it up a little bit like this, and essentially what I have is a measure of 3, a measure of 6, and I need to find this x over here, and that's going to be tan x equals 3 over 6, tan 1/2. So that's going to be inverse tan on my calculator. Inverse tan 3 divided by 6, 26.6. So x equals 26.6. And remember, the question asks for the entire angle here, which is the entire angle here, theta. So I'm just going to add the 90 from the leftover from the rectangle. So that's going to be 116.6. So theta equals 116.6, because I'm going to add the 90 to there. All right, so a few challenging problems. Give these other ones a try. There's usually a question of this sort on the provincial exam. 2 buildings, it comes up quite often. You just have to split your diagrams up and take them one step at a time. Okay, thanks for watching, and see you next time.